All right, we are on the practice rationals worksheet. So we're just practicing everything we've done so far this week. First thing is to simplify each expression. Leave denominators in factored form. You don't want to waste any time foiling any denominators out because it doesn't help you and it is likely to make a mistake. So don't do that. Okay, first thing, I see a backwards factor, meaning the variable is not first. So let's turn that around. We can do that by factoring a negative out. So that would make factoring a negative out would make this -5, and this would become plus x. And now that's really x minus 5. And the negative that you factored out will also get subtracted. So this is really 1 over x minus 6. Instead of minus negative, let's make it plus x over x minus 5. So instead of minus negative x over x minus 5, I just made this plus. All right, so what is the common denominator here? Because we're adding two fractions, we need a common denominator. It's x minus 6 times x minus 5. And each fraction gets multiplied by whatever it was missing to get that common denominator. So the first fraction has the x minus 6. It is missing the x minus 5. So that's what I would be multiplying by, top and bottom. So 1 times x minus 5 is x minus 5. I've already set up the common denominator, so there's not really anything to do for the bottom part. And then this x over x minus 5 has the x minus 5. It's missing the x minus 6. So that gets multiplied top and bottom. So now take this plus x and distribute it through the x minus 6. So plus x squared minus 6x. One thing you can do as you're studying for this next test, by the way, is to write out steps. When I'm adding rational expressions, what are the steps that I do? So anyway, I would do that as I'm going through this. Put this in the right order, combine like terms. X squared, x minus 6x is minus 5x. There's a minus 5 on the end. Keep the denominator factored out. There's no reason to FOIL that together. Do a quick check. Does this factor at all? No. The only numbers that multiply to 5 are 1 and 5, and there's no way those can add or subtract to -5. So this is my final answer. Okay. Number 2 is a complex fraction. Remember, I have a way to do this that is a bit more streamlined than doing the math here, and then flipping it to a multiplication problem. So I'm just going to say, okay, I have a 2 and a 4 and a 2. What is the least common denominator? Least common denominator is 4. We're used to seeing expressions here, but if I just say multiply the top and the bottom by 4, that's going to clear out all of those fractions, and it will make things a bit easier. All right, so what does that mean? Multiply by 4. So remember, you're doing now you don't have to write this down, but you're doing 4 times x over 2 minus 4 times x plus 3 over 4 over 3 times 4 minus x over 2 times 4. So the 4 over 2 will cancel out. That's 2x. And the 4 over 4 will cancel out. Careful here. Minus the quantity x plus 3. 3 times 4 is 12. And then here the 4 and the 2 will divide out to 2, so minus 2x. Remember to distribute the negative through. 2x minus x is x minus 3 over, I can factor a 2 out of that, 6 minus x. Factoring a 2 out doesn't really help me in the denominator at all, but I can leave it like that. You could factor a negative 2 out and get x minus 6 as well, but nothing cancels. So that's why it doesn't matter if I factor it or not. You don't have to show me this step in the middle. So if you can get right from here to here to here, that's why I consider this a more efficient way to get to the final answer. If you have the way that you learned in Algebra 2 or previous classes and you get to the same answer, that is perfectly fine with me. It's not that much shorter to do it this way. The reason I like this is because eventually all of these second semester, these will have trig expressions in them, like sines, cosines, tangents, and it might be easier to do it this way. Okay, number 3. I'm back to adding some expressions again. Before I start setting up a common denominator, let's look at what we have here. We have x minus y over, I can factor a 2 out, 2 times x plus y. And I have plus 3 over, I can factor out a 3, x plus y. This is nice because we can reduce by 1. We did this in our notes as well. So really the problem is x minus y over 2 times x plus y. Now it's just plus 1 over x plus y. So not having the 3 in there will allow us to work with smaller numbers. So now I need a common denominator. So the first fraction has 2 times x plus y, and the second fraction has nothing different. So that is the common denominator. The first fraction does not need to get multiplied by anything to have the common denominator, so I'm just going to copy it down, x minus y. The second fraction has the x plus y, but it's missing the 2. So I'm going to multiply by 2 over 2. 1 times 2 is 2. So I just put a little plus 2 up there. There's nothing to factor in the numerator, and there's nothing else to do in the denominator. So this is the final answer. All right, for number 4, we have a complex fraction again. Before you get started on this, you should factor. I can factor out x minus 3 and x minus 2. All right, so take a look at all of your denominators. Write down what the least common denominator would be for all those 3 things. X minus 3, x minus 2. There are no different factors than that. So that's what you're going to multiply by, top and bottom. All right. So let me try this without writing it out, because this is where I want you to get when you're doing this. 1 over x minus 3 will cancel with x minus 3. I'll be left with 1 times x minus 2. And then x minus 3 times x minus 2 will get multiplied by 1. There's nothing to cancel that out, so you're going to have to multiply those together. So that's what the numerator would be. The denominator, when we multiply 5 over x minus 3 times x minus 2 times x minus 3 times x minus 2, they would cancel out and you would just have the 5. Then from the second part, minus 1 times the x minus 2's will cancel. I'll be left with the x minus 3. So I did not show, like I did in the previous one, every single term being multiplied by x minus 3, x minus 2, because remember, the goal is efficiency here. If you would like to write all of that out, you can. It just will take you a little bit longer, and you're also trying to make sure that you're finishing within time, so it just takes a bit of practice. All right, what do we need to do here? We need to combine like terms, top and bottom. So x minus 2, if I distribute that 1 through. This 1 doesn't matter. I can FOIL these 2 together. So plus x squared minus 5x plus 6. Distribute this negative 1 through. 5 minus x plus 3. What do we have up here? We have x squared. 1x minus 5x is minus 4x. Negative 2 plus 6 is plus 4. Down here I have 8 minus x. I can factor the top a little bit. It's x minus 2 squared. The bottom is x minus 8, or 8 minus x, or you can factor out a negative if you want to. But I'm just going to leave it like this. Next one. We need to remember our exponent rules. When we are multiplying, when we're dividing 2 numbers with the same base and they have exponents, we subtract the exponents. Excuse me. So subtract. Okay. So what does that mean here? It means we subtract a to the 3x minus x times b to the 17 minus 20. That's a to the 2x times b to the negative third. And negative exponents get rewritten. So a to the 2x over b to the third. Our next chapter, chapter 3, is about exponential functions, and we will talk more about these exponent rules there. But you should know your exponent rules about when to add, when to subtract, and how to rewrite negative exponents. All right, for this one, This one looks terrible, but remember, just take it in pieces. So do I see a GCF in the top? No, but I see a trinomial. So I want to start splitting this up. Now use the middle term as a hint. I'm trying to get 9. My options for 10 are 1 and 10 or 2 and 5. So which one is going to come out to 9? Probably 1 and 10, right? So how do you break up 10x squared? 10x and 1x. Now go to the end. Minus x squared y squared. Excuse me. You have to break things up evenly. So the only way to break up x squared y squared is xy, xy. Just like the only way to break up x squared is x and x, right? So this is xy, xy. We're trying to get plus 9. So remember, 10x is going to get multiplied by this part. Xy is going to get multiplied by this part. So if I make this plus out here, I'll get plus 10 xy, x squared y, 10x times xy, 10x squared y. And in here, if I put a minus here, I'll get minus x squared y. And that's how you're going to get the negative or the positive 9 in the middle that you need. Okay, so I have my factoring. Get that out of there so it's not as confusing. What about the denominator? Now down here, I need to factor out a 3. Don't just start breaking things up. Look at it first. See if they're, especially if you have large numbers, see if there's something you can factor out. And more than just a 3. Look, they all have an x in them. They all have an x cubed. So let's take out a 3x cubed. That'll leave me with y squared minus 11y plus 10. How do we break up y squared? Y and y. How do we break up 10? 10 and 1, because I want 11. Make them both minus. And gosh, I missed my GCF on the first one too, didn't I? It looks like, hey, there's nothing to cancel here, but wait a minute. We could have factored an x squared out of this one, right? They all have this x squared. So 10, if we factor out a negative x squared, how about this? Well, no, let's just take out an x squared. 10 plus 9y minus y squared. All right, so let's go back and do that. Sorry, I'm probably confusing you a bit. What if I don't like having the y squared as a negative? I can say, okay, take out a negative along with the x squared. That makes this positive y squared minus 9y minus 10. Is that better to look at? I would say yes. So make sure that what you factored out makes it into your answer there. So the negative x squared is out there. How am I going to break up y squared? Y and y. How am I going to break up 10? 10 and 1. I want it to be negative 9, so minus 10 plus 1. All right, so what can cancel? Y minus 10s can cancel. X to the second over x to the third leaves you with 1 over x to the first, right? These x's cancel with all but one of those. So what am I left with? I'm left with a negative up top and a y plus 1. Left with a 3 down here. There's an x left over from x squared over x cubed and a times y minus 1. Nothing else will cancel. If you distribute the negative through, you can't cancel because you'll have negative y minus 1, not y minus 1. So that's as far as that goes. Now, this page says solve each equation for x. So we started off simplifying. Notice how all of my answers are still fractions, right? Keep the fractions around and see what you're left with. Here, the first step is to get rid of the denominators. Make sure that you show extraneous solutions crossed out. All right, so what are my steps for this? First, factor denominators to see what you're working with. This is x minus 3 times x plus 2. Make a note of what x is not allowed to equal so that you don't forget to throw those answers out. X can't equal 3 because then you'll divide by 0, or negative 2 because you'll divide by 0 in the other fractions. So if I get either of those two answers, it's actually no solution. All right. Multiply both sides by the least common denominator so that you wipe out the fractions. You're allowed to do that because you're multiplying both sides of the equation by the same thing. This is kind of like what we do with our complex fractions. So when I multiply this to the first term, the x minus 3's cancel, and I'm left with x times x plus 2. There's a minus sign right here. The x minus 3, x plus 2 will cancel with the x plus 2, x minus 3 here. You're left with 7x minus 6, but be careful because this minus should get distributed through the 7x minus 6. So anytime you have parentheses or two terms up here, just put parentheses around it. On the other side of the equals, the x plus 2's will cancel, and you'll be left with 2 times x minus 3. Now this is a linear equation to solve. Well, not linear. Now this is an equation that's not rational to solve, so I need to distribute and get rid of parentheses. So this becomes x squared plus 2x minus 7x plus 6 equals 2x minus 6. Clean things up on each side of the equation. This is a quadratic equation. I'm not going to be able to get rid of x squared, so if it's quadratic, it should be equal to 0. So I'm going to move everything to the left side. Subtract 2x, add 6, factor. Some of you are going right to quadratic formula, even though we talk about how much we don't like quadratic formula. Some of you are doing it instead of factoring, and then you're messing up somewhere. So factor when you can. This factors into x minus 4, x minus 3. If x minus 4 equals 0, then x equals 4. If x minus 3 equals 0, then x equals 3. Are either of those extraneous solutions? X can't equal 3, so that's extraneous. But x can equal 4. You can check your answers, by the way. If you were to graph, I would probably check in Desmos. But if you were to graph the left side of the equation and graph the right side of the equation, they should only intersect at one point, and that's x equals 4. All right, next one. Nothing to factor. We're multiplying. You can either think of this two ways. Multiply by the LCD, which is each denominator, right? Or what you can also do there is say, I'm going to cross multiply. It doesn't matter. You're going to have the same work either way. So for this one, it's going to be 5x minus 3 times x minus 1. And on this side, the x minus 1's cancel. It'll be 2x minus 3 times 3x plus 1. So if you just said, oh, I would just cross multiply, it's literally the same exact thing. It's just a different way of saying that. All right, so now what do we need to do? Get rid of parentheses. So this is 5x squared minus 5x minus 3x, so minus 8x plus 3. That equals 6x squared plus 2x minus 9x, so minus 7x minus 3. I want to get, this is quadratic, I want to get this equal to 0, and I want the x squared to be positive, so I'm going to move everything to the right side. So subtract 5x squared to get x squared, add 8x, and subtract 3. All right, now I need to factor this. X plus 3, x minus 2. So x could equal negative 3 or positive 2. Oh, what about excluded values? Sorry, forgot about that. X can't equal 1 or negative 1/3. I didn't get either of those answers, so 2 solutions. All right, number 9. How does this factor? Hopefully it factors into these two, x minus 6, x minus 2. You can use the other denominators to kind of help you out here, but yeah, that works. So multiply by the least common denominator, which is x minus 6, x minus 2 on both sides. So the first step you should be writing down, if you're writing down your steps for how to solve equations, after you factor denominators, multiply by the least common denominator. So get rid of fractions. All right, so what does this become? So this is x minus 6 is canceled. This is 1 times x minus 2 plus x times x minus 6 equals 4 times nothing because everything canceled. Well, this is just x minus 2. This is plus x squared minus 6x equals 4. This is quadratic yet again, so get it equal to 0. So x squared, then we're going to have minus 5x I have a minus 2, and I'm going to subtract 4 over to the left side to get this equal to 0. How does this factor? It factors into x minus 6, x plus 1, because I need to multiply to negative 6, and I need to add or subtract to negative 5. So x equals 6 and negative 1. Are either of those extraneous? I keep forgetting to do my extraneous values first. X can't equal 6 or 2. So 6 is out, but negative 1 is in. All right, let's take a look at number 10. So factor x minus 12, x plus 4. Does that work? That multiplies to negative 48. Negative 12 plus 4 is negative 8. So yes, that works. And then we need to multiply both sides of the equation by that common denominator, x minus 12 times x plus 4. So in the first term, everything cancels, and you're just left with 2x plus 1. In the second term, you're left with minus 3, and then the x minus 12s cancel, so times x plus 4. And it equals 5 times x minus 12, because the x plus 4s cancel. Distribute. 2x plus 1 minus 3x minus 12 equals 5x minus 60. Okay, clean up what you have on this side. So negative x minus 11 equals 5x minus 60. Let's bring this up here. This is not quadratic. This is just a linear equation. So I'm going to get my x's to the right side. So I'm going to add x to the 5x to get 6x over here. And then I have negative 11. I'm going to add 60 to that to get positive 49, right? 49 minus 10 is 50, minus 1 more is 49. All right, so, and then divide by 6. So x is 49 divided by 6, which is definitely not an excluded value. X was not equal to 12 or negative 4, this is neither of those. All right, let's take a look at 11. Factor this difference of squares, x plus y, x minus y. Multiply both sides of the equation by x plus y, x minus y. All right, so whole denominator will cancel from the first term. You just have 2 plus 3 times x minus y's cancel. So you're left with 3 times x plus y equals negative 3 times x minus y. Distribute. 2 plus 3x plus 3y equals negative 3x plus 3y. We're solving for x, and it looks like the y's are canceling out. There are excluded values. X can't equal plus or minus y. Otherwise, you'll get 0 in one of the denominators. So let's see. If we add 3x to this side, I get 6x. There's a 2 out there. 2 plus 6x equals, the y's are going to cancel out, equals 0. So 6, bring my work out here. So 6x equals negative 2, divide by 6. X equals negative 1/3. All right, so x is negative 1/3. Number 12, backwards factor here. So remember, we're going to say, I'm going to factor a negative out of that to make it x minus 2. And what does that do? Minus negative changes this to 1 plus 3 over x minus 2. So now I'm ready to multiply both sides of the equation by x minus 2, x minus 5. Nothing cancels from the 1, so I'm just going to have x minus 2 times x minus 5 plus 3 times x minus 2's cancel, so x minus 5 equals 1 times x minus 5's cancel, x minus 2. Let's get rid of parentheses, so I'm going to bring this up here. So FOIL these out, x squared minus 7x plus 10, distribute a 3, plus 3x minus 15, distribute a 1, you don't really need to do that, equals x minus 2. Clean up what you have. And then get this quadratic equal to 0. X squared minus 5x. If I add 2, I get minus 3. This doesn't factor, but it's a quadratic, so we can solve it still. X equals 5 plus or minus the square root of 25 minus 4 times 1 times negative 3 all over 2 times 1. That's 5 plus or minus the square root of 25 plus 12, so 37 all over 2. The only excluded values were x can't equal 5 or 2. This is neither of those, so those are my solutions. Okay, solve each inequality. When we're solving inequalities, we must keep denominators. You should be writing this large at the top of your paper just like I am, because the most common mistake after you just get done clearing out fractions because you're solving equations, the most common mistake is to keep doing that for inequalities. But with inequalities, remember, we're looking for where is this expression positive and where is it negative. And although clearing out the fractions can find part of the solution set, it does not find the whole thing, because this fraction can be greater than 0. It can be positive if the top is negative and the bottom is negative, because then they divide out to a positive, right? So you need to keep the fraction together. Okay, so what are the steps on this? Factor what you can. Plot the critical numbers on a number line. So I like to start by factoring the whole thing. So let's say this is x minus 3, x minus 2. This is x minus 8, x plus 6. Nothing cancels here, right? Okay, so what do we have? We have x-intercepts, or zeros, at x equals positive 3 and 2. There are vertical asymptotes at x equals 8 and negative 6. I know that we haven't officially talked about graphing, but you did in Algebra 2. And we've talked a lot this year about how you can't divide by 0. So these are places that we definitely can't have x equal to 8 or negative 6. The reason I make that distinguish between the two is because you need to know where to plot an open circle on your number line versus where to plot a closed circle. Put these numbers in order. Negative 6 would be farthest left, then 2, then 3, and then 8. Negative 6 and 8 came from the denominator, so they're open circles. Because this says greater than or equal to, 2 and 3 are where this fraction will equal 0, so they're filled in. Now, we need to test 1, 2, 3, 4, 5 different numbers, one in each of these sections. Test into your factored form. All right, so what am I testing? Something to the left of negative 6, like negative 7. Put into your factored form so you don't have as large of numbers to work with and you don't have to actually calculate much. So negative 7 minus 3 would be negative 10. Negative 7 minus 2 would be negative 9. Negative 7 minus 8 would be negative 15. And negative 7 plus 6 would be negative 1. I don't care about the number. I just care about the positive or negative. The top, negative times negative, will be a positive. Bottom, negative times negative, will be a positive. So overall, this divides out to a positive. Now, these graphs do often alternate, but you should just it doesn't take long to test. So you should test each number. Depending on what the multiplicity is of the factors, the graph might not change signs. What's between negative 6 and 2? Lots of numbers, but 0 is. I always like to put that in. If you put in 0, you could go back to the unfactored form. That would give you 6 over negative 48. Or you could say, okay, negative 3 times 0 minus 2, negative 2, over negative 8 times 6. That's a positive on top, but you're dividing by a negative. So that's negative overall. What's between 2 and 3? 2.5. Again, don't work too hard to crunch the numbers. You're just looking at positives and negatives. So 2.5 minus 3 is negative 0.5. 2.5 minus 2 is positive 0.5. You could even just write minuses and pluses here. 2.5 minus 8 is negative. 2.5 plus 6 is a positive. A negative times a positive is a negative. A negative times a positive is a negative, but that divides out to positive overall. What's between 3 and 8? I would pick 4. 4 minus 3 is 1. 4 minus 2 is 2. 4 minus 8 is negative 4. 4 plus 6 is 10. A positive divided by a negative is overall negative. And finally, what's to the right of 8? Try 9. 9 minus 3 is positive. 9 minus 2 is positive. 9 minus 8 is positive. 9 plus 6 is positive. You don't have to show me all of this checking, especially on that last one. If you can just look at it, plug 9 in mentally and say, oh, I'm getting positives for everything, that's good enough for me. Because this says greater than or equal to 0, we want the positives. So any section that came out positive will be part of our solution set. Using interval notation, this is negative infinity to negative 6 with parentheses. Square brackets, anything between and including 2 to 3. And anything from 8 to infinity. All right. For number 14, again, I cannot multiply x minus 4 to this side. What I need to do instead is subtract 2 to begin with. You always want your rational inequality to be compared to 0, just like we did with polynomials. Get a common denominator. So this whole thing needs to be over x minus 4, which means the minus 2 will get multiplied by x minus 4. All right, so if you do that, you get x plus 3. My pen stopped working. Just a minute. Still not working. Hold on. X plus 3 minus 2x plus 8 over x minus 4. That's negative x plus 11 over x minus 4 is less than or equal to 0. There's an x-intercept when the numerator is equal to 0. If negative x equals negative 11, x equals 11. There's a vertical asymptote at x equals 4. Plot 4 with an open circle, excuse me, and 11 with a closed, because this is less than or equal to. This is where it equals 0. You've got 3 numbers to plug in. What's to the left of 4? 0. You're plugging into this. Plug in 0, you get 11 over negative 4, which is negative. Something between 4 and 11, I would pick 5. Plug in a negative x, you get negative 5 plus 11 over 5 minus 4. That's 6 over 1. It's positive. Plug in something like 12, you get negative 12 plus 11 over 12 minus 4. Negative 1 over 8 is negative. We want the negative sections because this says less than or equal to. So my solution set is negative infinity up to negative 4, up to positive 4, and square bracket to include 11 out to infinity. Same idea with number 15. Subtract 5 to begin with. So this is greater than or equal to 0. Set up a common denominator. So minus 5 will get multiplied by x plus 1. Distribute the negative 5 through. Simplify. 2 minus 5, we've got negative 5x, and then 2 minus 5 is minus 3 over x plus 1 is greater than or equal to 0. What's the x-intercept? Negative 5x equals 3. X equals positive 3 divided by negative 5. And what's the vertical asymptote? X equals -1. So -1 is further to the left than -3/5. Careful with your number lines. -3/5 is closed because it came from the x-intercept, and this says greater than or equal to. Test three numbers, something to the left of -1, like -2. Plug it into the simplified version. So -2 times 5 is 10 minus 3 over -2 plus 1. That's 7 over -1. That's negative overall. What's between -3/5 and -1? Just go like -4/5, right? That's closer, but not quite -5/5. -4/5 times -5. Well, that's just the 5's cancel, right? The -5's cancel, so that's just 4 minus 3 over -4/5 plus 1. Now it's +1 on top. It's +1/5 on the bottom. So positive overall. What's to the right of -3/5? 0. That gives you -3 over 1, which is negative. We want the positive section, so there's only one of those. Anything between -1 and -3/5, and we're putting a square bracket on the -3/5. Last problem. Again, you cannot cross multiply and clear out fractions. So instead, we subtract the fraction from the right side over to the left side. So now this is less than 0. And we set up a common denominator. So the common denominator is x plus 1 times x minus 1. 2x plus 5 will get multiplied by the other denominator, x minus 1. Minus parentheses, x plus 1 will get multiplied by x plus 1. Because it was missing, it had the x minus 1. Okay, that means that we need to FOIL stuff together. 2x squared minus 2x plus 5x. It's plus 3x minus 5 minus parentheses x squared plus 2x plus 1. Leave your denominator factored. We need to combine like terms up here. So we have x squared minus 2x squared minus x squared is x squared. 3x minus 2x is plus x, -5 minus 1 is minus 6. So we've combined all of our like terms in the numerator, and that leaves us with something we can factor. This is x plus 3, x minus 2, over x plus 1, x minus 1. That's a lot of values, right? There are two x-intercepts. The x-intercepts come from setting the numerator equal to 0, x equals -3 and +2. The vertical asymptotes are at plus or minus 1. So we come up to a number line. -3 is the farthest down. Now I have open circles for everything because greater than does not include the x-intercepts. So we're putting open circles there. It's not less than or equal to. I said greater than. I meant less than. Just plain less than. There's a -1. There's a +1. And there's a +2. We have 1, 2, 3, 4, 5 sections to test. And you're testing into this factored version here. So start with -4. That gives me -1 times -6 over -3 times -5. Negatives all around, that gives you positive over positive. So that section is positive. What's between -1 and -3? -2. -2 plus 3 is 1. -2 minus 2 is -4. -2 plus 1 is -1. -2 minus 1, -3. Negative on top, positive on the bottom, negative overall. Plug in 0. 3 times -2 over 1 times -1. Negative on top, negative on the bottom, positive overall. What's between 1 and 2? 1.5. 1.5 plus 3 is positive 4.5. 1.5 minus 2 is negative. 1.5 plus 1 is positive. 1.5 minus 1 is also positive. Negative over positive, negative overall. And finally, 3. 3 plus 3 is positive. 3 minus 2 is positive. 3 plus 1 is positive. 3 minus 1 is positive. That's positive. Which answers do I want? I want the negatives because I'm looking for when is this fraction less than 0. So here and here. Negative 3 to negative 1, parentheses, positive 1 to positive 2. Do these take a lot of work? Yes. But out of all the skills we learn in pre-calculus, this is one of the most important for calculus. We will be testing numbers on number lines all the time when we're looking at derivatives, help us make decisions about function behavior, concavity, all kinds of stuff. So this is an important skill. You do need to be able to do it this year and next year.